Hi everyone, in this video we will learn about arithmetic sequences, lesson 4.7. Okay, so first of all, a sequence is a list of numbers with a continuing pattern. An arithmetic sequence, so like the word arithmetic, has adding or subtracting a pattern to get the next number. In these problems we have to describe the pattern and then find the next two terms in the sequence. Okay, so we're going from the numbers 6 to the number 13, so that's add 7. Go from 13 to 20 is add 7, and 20 to 27 is add 7. So the pattern is add 7, which means that the next two terms would be 27 plus 7, so that would be 34, and then 34 plus 7, which is 41, so the next two terms. Okay, in the next pattern, it looks like we are adding 4, adding 4, adding 4, so the pattern is add 4, and the next two terms are 18 and 22. Okay, in the next one, we're going 8, 4, 2, 1, so it looks like we're dividing by 2, divide by 2, divide by 2. So 1 divided by 2 is 1/2, and 1/2 divided by 2 is 1/4. In this problem, we're telling whether a sequence is arithmetic if it is identify the common difference. Okay, so learning these vocab words, an arithmetic sequence. An arithmetic sequence is a sequence, so a list of numbers, where the pattern is to add or subtract the same number. The common difference would be that same number. Okay, so looking at this first one, 5, 8, 11, 14. So we're adding 3, add 3, add 3. So since we're adding the same number to every term, then yes, this is an arithmetic sequence. And then identifying the common difference, CD for common difference, the common difference is 3, because we are always adding 3, adding 3, adding 3. The word difference means subtract, and that's because we could take any two terms like this 8 and this 5, and 8 minus 5 is 3. Okay, so next example. Okay, so the first question, is this a arithmetic sequence? And it is yes, because we are minus 2, minus 2, minus 2. So yes, it's an arithmetic sequence, and the common difference is the pattern, so in this case, minus 2. Next one, we're going from 3 to 6 to 12 to 24, so what we're doing is multiply by 2, multiply by 2, multiply by 2. Therefore, this is not an arithmetic sequence, and there's no common difference, so we would just write the word no. Now learning something new, this idea of a recursive formula. Okay, and here's an example of a recursive formula. Okay, so a recursive means to use the previous term in order to get the next term. Okay, so first of all, this symbol a of n could represent like a y. Okay, and this a n minus 1 will actually represent the previous term. Okay, and then a recursive formula always has to give you a starting place. A of 1 is 4. So what that means is that on our table, so in our table we have n and a of n, and we can fill in 1 for n, that's from this one right here, and 4 for a of n. Now, if you want to find a of 2, in other words, the second term, a of 2 would be filling in a 2 wherever there's an n, so filling it in here and here. A of 2 equals a of 2 minus 1 plus 3. Okay, so then a of 2 minus 1, so 2 minus 1 is 1, so a of 2 equals a of 2 minus 1 is 1 plus 3. Okay, well, a of 1 is right here. A of 1 is 4. So a of 1 is the previous term. Okay, so the second term is the previous term plus 3. So the previous term was 4. So we're filling in a 4 for a of 1. And then bringing down the plus 3. So a of 2 equals 4 plus 3, which is 7. The next term, a of 3, would be the previous term plus 3. So the previous term was 7. So all we have to do is take the number 7 and add 3, and we get 10. The fourth term would be the previous term 10, but then add 3, so 13. So in this example, what these symbols actually mean, so a of n would represent a y. So we could say that is the term. The term, whatever you happen to be on, is, then this entire box right here, a of n minus 1, is simply the previous term. Or in this case, the previous y coordinate. And then you bring down the plus 3. So what this says is the next term in the sequence is the previous term plus 3. So that's why we need another piece of information here. We have to be given where we're actually starting from. So we would have to say that, well, we're starting our first term 1, our first term, we're starting at 4. So we're starting at 4, but then it's the previous term plus 3. So the pattern would be start at 4 and then add 3. 7, 10, 13, etc. And if we take a look up here, that's this list here. 4, 7, 10, 13, etc. So writing a recursive formula for the sequence, first thing I'm going to notice is it's add 3, add 3, add 3. Okay, so now this idea of a recursive is that the new term equals the previous term plus the pattern, or plus the common difference. So in this case, the pattern is plus 3. So the term, I'm going to call that a of n, is the previous term, which in symbols is a of n minus 1, plus the pattern, which is 3. But this is not enough information because I have to be given where to start at. So the pattern is that you're always adding 3, adding 3, adding 3, but I have to know where the pattern starts. So this pattern starts at the number 7. So since it starts at 7, I'll write that a of 1, in other words, the first term is 7. Now I have my complete recursive formula. The pattern starts at 7, and it's the previous term plus 3. Here the pattern is minus 4, minus 4, minus 4, because 0 minus 4 is negative 4. Okay, so then our recursive formula would be, so the new term, a of n, is going to be the previous term means a of n minus 1, plus the pattern, so in this case, minus 4. But then the pattern starts at the number 8, So we have to write that our first term, a of 1, our first term equals 8. Now I have the complete recursive formula. Here we have to write an explicit formula for each recursive formula. The word explicit formula just means a plain old normal formula that does not require a previous term. Okay, so understanding this, first of all, this says that the term equals the previous term. Whenever we see this symbol a parenthesis n minus 1, that translates to the previous term plus 12, where the first term is 4. So this pattern starts at the number 4, but then we keep adding 12 to the previous term. Okay, so the list of numbers would be 4, then add 12, so 16, add 12, so 28, add 12, so then 40. So it starts at 4, and then keep adding 12. On a table, this would look like this, because we are starting at 4, and we keep adding 12 to the outputs. Okay, so writing just a regular old formula for this, we could say that the total y, or the total a of n, equals that it starts at 4, and then from there we're always adding an additional 12 for every x. But in this case it's n, and we're off by 1, so we can write n minus 1 and attach a 12 to that. Another way to think of this is that if we extend this pattern, okay, so if our values are going up by 1, then we would be at 0, and if we take away, so here we're adding 12, so if we subtract 12, we would get to negative 8. Okay, so that means that the table includes the points 0, negative 8. So if we write an equation with the point 0, negative 8, then we're at y equals, and it starts at negative 8, and then it adds 12 for every x. Okay, and where y is really a of n is negative 8 plus 12n. So that's another way to think of it. Thank you for watching this video.